My name's Jeff.
My name's Allie.
My name's Rob.
My name's Liz, and we're
Jarl!
Here at Jarl, we like to solve dynamics problems. What are we going to solve today? Well, let's look into the jar of Jarl. Look behind you. Oh my gosh, problem number 4, my favorite! So, with this problem, we're given a tape rolling around 2 drums of different sizes. And we're given the tension in A, but we're not given the tension in B, or the tensions between A and B. So we need to find that, don't we? So let's take a look at what we're given for this problem. We know initially the system starts at rest, so the velocity is 0. And then after 0.24 seconds, we know the velocity of the tape is 10 feet per second. We're also given the radius of gyrations for both drums A and B, as well as the actual radius of the drums. We know that the tension in the tape at point A is equal to 0.75 pounds, and we know that the weights of the drums are 1.4 pounds for A and 3.5 pounds for B. On to you, Allie.
How are we going to solve this? Let's check the jar of Jarl. Impulse momentum theorem, my favorite. The impulse momentum theorem is the initial momentum of the system plus the impulse acted on the system, which is equal to the final momentum of the system. To do this, we had to split our problem into 2 parts, drum A and drum B. We also had to make a few assumptions. We assumed that gravity is equal to 32.2 feet per second. We also neglected the force in the x and y direction as well as the friction force. And finally, we had to assume that the tape has the same velocity throughout. To solve this, we have to isolate drum A and use the impulse momentum theorem to solve for tension in AB, since we're given the tension in A. Then we isolate drum B and use the impulse momentum theorem again and the value we solved for TAB to solve for TB.
Alright, so you guys are probably wondering how we're going to do this. Well, let's check the jar of Jarl and find out. We're going to use moment of inertia and angular velocity to start this problem. So, as you can see here, the moment of inertia is equal to the mass of an object times the radius of gyration of that object squared. So, we know the mass of A and the radius of gyration of A, so we simply plug in our 2 numbers there and account for units, and we get our moment of inertia of A as 169.837 times 10 to the negative 6 pounds second squared feet. We do the same for B, except we plug in the mass of B and the radius of gyration of B, because it will have a different moment of inertia because the size is different, and we get 1.17942 times 10 to the negative 3 pounds second squared feet. Alright, so now our next part is determining the angular velocity of our 2 objects. So the angular velocity is equal to the linear velocity divided by that object's radius. So, accounting for units, we get our angular velocity of drum A in terms of V as 13.33 V, and then we do the same exact thing, accounting for the different radius of B and accounting for units as well, and we get our angular velocity of drum B as 8 V. So now, because we know the velocity at 0.24 seconds as 10 feet per second, we simply plug in 10 feet per second into each of these, as you can see right here, and we get our 2 angular velocities. Our first angular velocity, or our angular velocity of A, is 133.33 radians per second. And then our angular velocity of B is 80 radians per second. Now here's Jeff to tell you what to do with the rest.
We now have everything we need in order to solve for tension in A and B, and also in tension in B. We'll start off applying the impulse momentum equation to drum A, and this is the equation broken down into basic terms. This here is the net impulse acted on drum A, and this is the final momentum of A. Plugging everything we have into the equation, we can solve for TAB. If I reach into the jar of Jarl and find it equals to 2.01 pounds. Now we do the same thing for drum B in order to find tension in B, and if everything comes out correctly, we get 5.15 pounds tension in B. Alright guys, now this concludes our solution to problem number 4. Thank you for attending the Jar of Jarl.